Okay, y'all, this unit is going to be over properties of triangles and inequalities of triangles. So we're going to be continuing to talk a lot about triangles. Specifically, the first couple of days, we're going to be talking more about the properties. And then the last 2 days of this unit, we'll be talking about the inequalities of triangles. So the first thing we're going to look at here is something called the Euler line. And actually, you may hear it called the Euler line or the Euler line. Regardless, it is pretty cool. There's some guy with the last name of Euler that figured out that if you have, what we're going to find out this unit is there's something called a circumcenter, a centroid, and an orthocenter. And what he discovered is that, and again, you don't know what these things mean yet, but what he discovered is that these three things all are going to lie on the same line. Okay, which is pretty uncommon, really, if you think about it, that we know that any 2 points make a line, but not every 3 points make a line. So for these 3 points to all end up being on the same line is pretty cool. And we'll see later is that these two pieces are going to have a 2-to-1 ratio. So it's not super important right now, but we will look at that a little bit more later. Okay, and so what we're first going to talk about is that we're going to look at 4 different terms that have to do with triangles. We're going to look at something called altitudes, medians, perpendicular bisectors, and angle bisectors, all of which we've talked a little bit about before in the past. But all of these different lines that we're going to see going through triangles, we're going to have 3 lines that we could draw in every triangle because every triangle has 3 sides and 3 vertices. And so the point where these 3 lines are going to run together or intersect is going to be this position right here, okay? So this point right here where these 3 lines connect is going to be called your point of concurrency. Okay, so you can see that all 3 lines intersect at that same point. We can just call that like maybe point P, and that's called your point of concurrency. Okay, and these points are all going to have different words specifically depending on what we're talking about. Okay, for example, if we're talking about medians, it's going to be called a centroid. If we're talking about altitude, it's going to be called an orthocenter. And so there's going to be these different words that we'll look at along the way. But for all of these, that's always called the point of concurrency. Okay, just a little bit of terminology that you're going to need to know. The word inscribed and the word circumscribed. Okay, so inscribed, if you notice here, we have 2 shapes, right? We have a rectangle and we have a circle. So your inscribed is going to be when you have a polygon. In this case, it's a rectangle. You're going to have a polygon inscribed, so it's inside of your circle. So your polygon is inside your circle. Okay, and so that's when it's called inscribed. So think about inscribed as inside. What you have to understand here, though, is that it's inside of the circle, okay? Because there's always going to be something inside of the other thing. You have to understand what is inside. So in this case, your polygon, in this case a rectangle, is inscribed inside the circle. Circumscribed is going to be when your polygon is outside of the circle. Okay, so everything's revolving around a circle. The only thing that's changing is the type of polygon that you have. So if you have a circle, and then in this case we have a hexagon, it is circumscribed outside of your circle. Okay, so here we have inscribed as inside your circle, and you could even put the polygon is inside your circle. And for circumscribed, you have your polygon outside your circle. Sorry, I know that's really bad handwriting. Okay, so just a couple of words that you're going to need to know. Okay, so starting now, we are going to start off with the first we're going to look at 2 main theorems today, and we'll look at 2 more the next day. So the first one that we're going to talk about is called your perpendicular bisector theorem. Okay, so this is a theorem. No, there's not going to be any proofs this unit, so you don't have to worry about using this in a proof this unit, but you do need to know it. So here's what the perpendicular bisector theorem says. And really, let's just break those two words apart. So perpendicular, we know, means 90 degrees, okay? Bisector means to cut in half. And so what we have here is a line that's drawn, and not only is it perpendicular to another line, but it is also cutting a line in half. And so if you look at this first picture right here, you can see that CD is 90 degrees, and it's also cutting this side in half. And so the theorem says, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Okay, so what that is trying to say here is that if you have a point, so in this case, you have point C, okay, on that perpendicular bisector, it is going to be equidistant from the endpoints of the segment. Okay, so not only do I know that AD is equal to DB, but I also know that AC is going to be equal to CB. Okay, because I know that is a perpendicular bisector. But the main thing you need to get out of perpendicular bisector is that it's going to be 90 degrees and it's bisecting that side. On the flip side of that, remember that word converse? That's basically mean we're flipping the sentence around. If you see that a point is equal distances from those endpoints, and you see that it's 90 degrees, and you also see that those little pieces of segments are congruent, then you know that it is a perpendicular bisector. Okay, so those things tell you that it would be. So here we're going to look at this picture, and this says if WZ equals 14 plus 9, or 14.9, sorry, and we need to find WX. So notice here, they're showing us that this is perpendicular and it's bisecting that side. And if that's the case, then I know this point W that's on that line, I know it is going to be equal distances from the two endpoints. And so this really is as easy as it looks. If WZ is 14.9, so is WX. So it is also 14.9. Okay, number 2. Okay, if WX is 4A minus 15 and WZ is A plus 12, find WX, okay, which means we need to find A first. Okay, and so here I would do 4A minus 15 equals A plus 12. And I'm just going to solve for A. So I'll subtract A from both sides. Okay, I would get 3A. Sorry, I'm kind of running out of room here. 3A minus 15 equals 12. So I'm going to write it up here. 3A minus 15 equals 12. Add 15 to both sides. So 3A equals 27. And divide by 3, so A would be 9. So if they actually want me to find WX, I just need to plug 9 in for this A. So 4 times 9 is 36, minus 15, so WX would be 21. Okay, remember too, since this is a video, if you need to pause this, then pause it. Okay, I'm going to erase all of this just so I have more room for this next part. All right, so now, so WX is equal to 25.3, and YZ is equal to 22.4, and they're wanting me to find XY and WY. Okay, and so what I know about XY is I know it's equal to YZ, and so XY I know for sure is 22.4. Okay, and so now we have to think of a way to find WY. Okay, well I know that these lines are perpendicular. Okay, which means what kind of triangle is this? This is a right triangle. And so How do you find the third side of a right triangle? You do Pythagorean theorem. Okay. And so I am going to do, let's see if I can find some space for this. I'm going to do 25.3 is my hypotenuse here. So I'm going to do x squared plus 22.4 squared equals 25.3 squared. So lots of fun numbers here. So 22.2 squared, that'd be x squared plus 501.76 equals 25.3 squared, which is 640.09. If I subtract that 501.76, I will get x squared equals 138.33. I'm going to take the square root of that. And 11y would be about, we're just going to round this to 11.761. Okay, so perpendicular bisector, all about knowing that it's perpendicular and cutting that side in half. Okay, now we're going to talk about probably one of my least favorite words, which is circumcenter. The circumcenter is the point of concurrency. So we talked about that earlier. That's when the three lines are going to intersect of triangles perpendicular bisectors. So if you look at this picture over here, okay, you can see that I have all types of perpendicular bisectors, and these are actually cut off. So like I have one here, I have one here, and I have one, this is a really bad picture, but I have one here. And so this point right here where they are all intersecting is your circumcenter, okay? And so what we know with this circumcenter is that PB, so if you look at PB right here, PA and PC, those are all going to be equal. Okay, and what's special about those is that is the distance to each vertices. And so those distances are all going to be the same. Okay, now what I want you to also pay attention to are these three pictures here in the middle. Okay, so notice where your circumcenter is in each one of these pictures. And notice that that circumcenter is not always inside of your triangle. It could be outside of your triangle. Okay, so if it's acute, it's going to be inside. If it's obtuse, it's going to be outside. And if it's a right triangle, it's actually going to be on your triangle. Okay, so now let's look at these three questions. Okay, so the measure of PDB. So PDB. So if that is my perpendicular bisector, then perpendicular means that that's going to be 90 degrees. Okay, number 2 says PB is 16, and it wants me to find PC. Okay, well they said that P right here, it says P is the circumcenter. And remember what we said up here in this picture. This is the circumcenter theorem. So what that says is that they're going to intersect at the circumcenter and that it is equal distances from the vertices of the triangle. So if BP is 16, so is PC. Okay, so now number 3, if AC is 10 and PB, okay, and I'm going to erase what I already did up here. Okay, so if AC is 10 and PB is 13, they want me to find PF. Okay, so here, if AC is 10, I know that from A to F, that's going to be 5. Okay, and I know if PB is 13, so is this other little dashed line from A to P. So that's 13. And then look at what we have here. We have another right triangle. And so I would have 13 would be my hypotenuse. So I would have 5 squared plus x squared equals 13 squared. So that's 25 plus x squared equals 169. If you subtract 25 from both sides, you get x squared equals 144 square root. And so x would be 12. Okay. Now, along the way, I am going to give y'all, because there's going to be 4 words like circumcenter that you're going to need to know. And they are not easy to keep separate from each other. And so I am going to give y'all some ways to remember these. And it's going to sound really silly when I say them, but just write them down. And if you'll remember them, it will help you a lot. And so the word that I'm going to give you for perpendicular bisector and circumcenter is the word public. Okay, but I want you to write it like I write it. So it's going to be capital P, lowercase u, uppercase B, lowercase l, lowercase I, capital C. So public. Okay, and if you look in here, you can see P and B are both uppercase. So that stands for perpendicular bisector, and C is going to be circumcenter. So your perpendicular bisector has a circumcenter. Okay, I'm going to give you 4 words that are similar to this, and I think it'll really help you because really these words start to get a little jumbled if you don't have a way to remember them. All right, so this says 3 homes, A, B, and C, need to share the same main utility pole. Where should the main pole be located? Okay, so if we have basically this triangle here, okay, and we need a utility pole that is equal distances from those 3 homes, then it would need to be at the circumcenter. And so that's all this is saying, is that it would need to be at the circumcenter. This next one is very similar. So a stove S, sink K, and refrigerator R are positioned in a kitchen as shown. Find the location for the center of an island workstation so that it is the same distance from these 3 points. So if I wanted a point that was the same distances from these 3 points, you would have to know that means that we need a circumcenter. So not any work you need to do here. You just need to understand that it's the same distance from the 3 points. That means that it's going to be a circumcenter. Okay, so here's just a few more circumcenter questions. So it's telling us O is the circumcenter. Okay, think about what that means. Okay, so you have to understand circumcenter means those are all perpendicular bisectors. And you also have to understand that they're equal distances from your vertices. Okay, so here they want me to find MP. Okay, so MP. So I can see that MS is 22. Well, if this dashed line here is a perpendicular bisector, I know that that's 90 degrees. I also know that these 2 pieces are equal. So if MS is 22, SP is also 22, which means MP would be 44. Okay, so now the perimeter of triangle MNP. So we're going to use that same idea because all of these dashed lines are my perpendicular bisectors. So if RN is 26, RP would be also 26. And then if MQ is 20, MN would also be 20. So if I want to add up all of that to get my perimeter, it would all add up to be 136. Okay, now it wants me to find OR. So that's this little piece right here. And so let's think about what we now know. Okay, and so we do know that this side is 26. Okay, remember we also know that this circumcenter is equal distances to each vertices. And so if this piece right here is 26.8, so is this piece. So this, my hypotenuse in this case, would be 26.8. okay? And so I would have to find OR. I would have 26 squared plus x squared equals 26.8 squared. Just to save a little bit of time here, I'm just going to tell you that OR would come out to be 6.499. Okay, so now to find OS, so that's this piece right here, we would just do the same thing because we know that this side's 22, we know the hypotenuse is 26.8. And so I would do 22 squared plus x squared equals that 26.8 squared again. And again, just to save some time, I'm going to tell you that OS would be 15.305. Just doing Pythagorean theorem there. Okay, this next question is a little bit confusing, okay, but try to make it as simple as possible here. So given triangle ABC, and it gives us what A, B, and C are, find the equation of the perpendicular bisector of AC. So you need to think about what that means. So perpendicular we know means 90 degrees. Bisect means to cut in half. Okay, and this answer right here, this is actually the answer. So if I wanted y'all to work this in class, I would just have you check your answer. But we're going to work this together, so I'm just going to mark that out. Okay, so I need to first plot those 3 points. So if I do this too fast for you, just pause it. Okay, and just make sure when you are plotting these points that you do label them. Okay, so you should have A, B, and C here, and I am just going to go ahead and connect these so I can get a better idea of this triangle here. Okay, so we want the equation of the perpendicular bisector of AC. So again, think about what that means, okay? We need AC not only to be cut in half, but it also needs to be perpendicular, okay? And so we need whatever equation. Now let me point this out. Perpendicular bisector does not have to come from a vertex. That is very important. Perpendicular bisector does not have to come from a vertex. A lot of the ones we've seen so far have come from a vertex. It does not have to. And so if you were to visualize a line that cut this line in half and it was 90 degrees, it would look something like this. Notice this end point of that does not come from a vertex. So ultimately what we are trying to do here is to get the equation of that line. Okay, so let's think about what we know first about perpendicular. So perpendicular, we know that those types of lines have opposite reciprocal slopes. So if I find the slope of AC, then I can take the opposite reciprocal of it to get my line. Okay, a couple of ways you can do that. You can use the slope formula, or you can just count and do rise over run, and that's actually what I'm going to do just to save some time. And so if I did rise over run here from C up to A, it's up 1, 2, 3, 4, 5, 6, and it's over 1, 2, 3, 4. So it's 6 over 4, which reduces to 3 over 2. So we know the slope we're going to use for our equation needs to be the opposite reciprocal of 3 over 2. So the slope we're going to use is negative 2 over 3. Okay, that's the opposite reciprocal. Okay, well, what else do we need to write an equation? We also need a point, right? We have a slope, we need a point. So we need to figure out what point this is where those two lines intersect. Okay, well, if it is the bisector, that means that we need to get the midpoint. We need to get the middle. Okay, and so I am going to find the middle of AC. Okay, and I'm going to use the midpoint formula. So we know that that means we need to add the x's. So I'm going to find the midpoint of AC. So I'm going to do 6 plus 2 divided by 2. And then I'm going to do 2 minus 4 divided by 2. Okay, and the midpoint that's going to get me is 6 plus 2 is 8, divided by 2 is 4. And 2 minus 4 is negative 2 divided by 2 is negative 1. Okay, so now I have a point, and now I have a slope. Okay, so my go-to is to put this in point slope. You may work this a different way, but that's what I like to do. So that's how I'm going to do this. So I'm going to put it into point slope. So I'll have y minus y1. So it'll be y minus negative 1. That's going to change to plus. Equals negative 2 over 3 times x minus my x value, which is 4. And now I'm going to distribute. So y plus 1 equals negative 2 over 3x plus, that'll be 8 over 3. Okay, now I'm going to subtract 1. So I have y equals negative 2 over 3x. And if I do 8/3 minus 1, that's like 8/3 minus 3 over 3. So that's plus 5 over 3. Okay, this is what my answer would be if they asked for slope-intercept. If you look at what I crossed out up here, this is the answer, but this is the answer in standard form. If I wanted to get this in standard form, I just move my x to the other side. So that would be 2/3 x plus y equals 5/3. Then I get rid of the fractions, so multiply by 3. And that would give me 2x plus 3y equals 5. Okay, it did not specify here what kind of equation to write. I just wanted to do both just to practice that. We'd probably just have you stop at the y equals mx plus b. All right, the next thing we're going to get into, which is not as much, so the rest of this will go faster, is angle bisector. We've talked about angle bisectors before. That's just when your angle is cut in half. And so what's important about the angle bisector theorem is if you have this angle bisector here, like BF, it is going to be equal distances from the sides of your angle. And so in this case, DF is equal to FE. They're also going to be perpendicular to those sides. So not only does your angle bisector mean those little angles are equal, but it means all those other things too. So on the flip side of that, if I look at the converse, if I see that these sides or these little pieces are congruent, and then those are right angles, and that those angles are congruent, I could then say that this is the bisector of that angle. All right, so here we go. So number 1, it wants me to find xy. And so I can see that these angles are congruent right here, so that means it's an angle bisector, which means xw and xy are going to be equal distances from those sides of that angle. And so if xw is 7, then xy is also 7. Number 2, they want me to find the measure of angle JKL. Okay, and notice here, they're showing me that these are equal distances from those sides and they're perpendicular, which means this is an angle bisector. So JKL would be 37 degrees also. Then number 3, notice here they're showing us, so they're asking for MS. They're showing us this is an angle bisector, which means these pieces are going to be equal. So I do 3x plus 5 equals 6x minus 7. You subtract 3x, and I'm also going to add that 7. You get 12 equals 3x, so x would equal 4. Okay, and so when you plug that in to actually find what they're asking, which is ms, you'd have 3 times 4 plus 5, so ms would be 17. Okay, so with perpendicular bisectors, we saw the word circumcenter. With angle bisectors, we're going to see the word incenter. And this is the point of concurrency of a triangle's angle bisectors. So if you look at this picture, if we have an angle bisector here, an angle bisector here, and an angle bisector here, the point where all of those meet is going to be called your incenter. Okay, and here is what's super important about that. Okay, your incenter, if P is the incenter, okay, then what you know is PD is equal to PE is equal to PF. So those distances to the sides where they're 90 degrees are going to be congruent. Okay, I'd say in the whole realm of geometry, that's not the most important thing you're ever going to learn, but it is something you need to know about the in-center. Okay, so they're telling me in this problem that J is the in-center. Okay, so think about all the things we know from them telling us that. We know that right now we have some angle bisectors in this problem. Okay, we also know that these pieces where they're showing us these are right angles, we know all those little pieces are going to be congruent. Okay, so there's a lot of things we know from them just telling us that's an in-center. Okay, so we want the measure of DCF. So DCF. So if that is an in-center, then I know that this angle C is being cut in half. And so if that side's 32, so is the other side. So that whole angle DCF would be 64 degrees. Okay, the measure of BAC, so BAC, okay, we don't know either one of those angles right now, okay, but that's okay because we do have a lot of information in this triangle. So we know right now, we just figured out this angle C, that whole thing was 64. Okay, we can figure out where angle B is because if this little piece is 34, so is this other piece. So that whole angle would be 68 degrees. And now we know two of the angles in that big triangle, so we can find the other one. So if I subtract those from 180, I'm going to get 48 degrees. So this whole thing is 48, which means each one of those would be 24. Okay, and then they want us to find JF. So JF, where is J? Oh, J is the middle. So J is the in-center. So if I want to find JF, what I now know is that, okay, I know this side here is 15. Okay, and I know that from F to A, it's going to be 12. And so now I can just do Pythagorean theorem to find that other side. So I'd have A squared plus 12 squared equals 15 squared. And just to save some time, what you end up getting is A is 9. So JF is 9. Okay, we are almost done. All right, you're building a triangular koi pond, and you would like a fountain in your pond. The fountain sprays water in a circle. You want no water to spray outside of the pond. Thus, you need the fountain to be the same distance to each side. Notice this is saying the same distance to each side here. The problems we saw before were the same distance to each angle. So same distance to each side in order to prevent water spillage. How would you determine where to place the fountain? And so here, obviously, this would be, we'd want to place it at the in-center. So it would be the same distance to each side. Same thing on this next one. You want to place a centerpiece on a corner table so that it is located the same distance from each edge of the table. Make a sketch to show where you should place the centerpiece and explain your reasoning. So if I were to draw, okay, a point that was equal distances, okay, I would want to draw first, okay, probably the right way to do this is to draw in all of these angle bisectors. So if I draw all of those angle bisectors in, this is the point of concurrency. That is our in-center. Okay, and so that would be our in-center. Okay, and our reasoning would be because they're equal distances to each side. All right, last slide. All right, so P is the in-center. If the measure of GFP is 29, so that's this little angle up here is 29. Find HFP. So HFP, that's this other little side of that angle, so that's also going to be 29. So now, if the measure of PGX, so PGX is 33, and the measure of HFP is 18. Probably need to take that 29 off from before. Find the measure of GHF. So where is GHF? So that's this whole thing right here. So this is similar to what we did earlier. So up here where the 18 is, I know that other side is 18. With the 33, I know the other side is 33. So if I add up the 18s, that's 36. If I add up the 33s, that's 66. And so that would leave this whole other angle. If I subtracted those from 180, that would be 78. Okay, and I'm going to erase this stuff again just so I can start over for the next one. Okay, so PG is 10, and GX is 8, and it wants me to find PY. So you're thinking, okay, well, that has nothing to do with where I'm at right now with the 8 and 10, but it does, because remember, these are all equal distances from the sides. So if PY, if they're wanting me to find PY, I just need to find XP, and then that'll get me PY. So I do X squared plus 8 squared equals 10 squared. And when you do all that math, you end up getting X is 6, which means PY is 6. Okay, and then this last one, if PX is 12, FZ is 5, that's not drawn to scale, find PF. So again, these three lines here that you see in red, I just put purple over them, those are all equal distances. So if PX is 12, so is PZ. And then now I just need to find PF. Be careful on this one. It would be really easy to think that ZF is your hypotenuse here. Just visually, it kind of looks that way. But make sure you figure out your hypotenuse is going to be the one opposite your right angle. So if I do 5 squared plus 12 squared equals x squared, I end up getting that PF is going to be 13. Okay, the word, so I gave y'all a word to help you remember perpendicular bisector, right? I gave you the word public. Okay, and we said that that was the perpendicular bisector had a circumcenter. That's what that word just helps you remember, so that if you had a triangle, okay, all of your, this is probably not going to be drawn to scale, but all of your perpendicular bisectors would all meet. Don't draw this. This is a terrible picture. Okay, but all of them would meet up at this point, which was called your circumcenter. Okay, the word I'm gonna give you that's gonna help you remember in center is gonna be the word cabin. So lowercase c, capital A, capital B, capital I, capital N. And so what this will help you remember is that an angle bisector has an in-center. So angle bisector has an in-center. So when we had all of those angle bisectors from before, so I had an angle bisector here, an angle bisector here, and an angle bisector here. They all met up right here, which was called your in-center. So again, this cabin word, that's no mathematical word, but it just helps you remember that that's called the in-center. Okay.